Assalamualaikum and greeting everyone, especially to my panel PSM1, Dr. Muhammad Taufiq bin Taib and TS Muhammad Harizal bin Osman. My name is Aliza Nadira binti Rosli and my matric number is B0919106164. I am supervised by Dr. Muhammad Ilman Hakimi Chua bin Abdullah and my bachelor degree project 1 is study on the extreme pressure properties of treated waste cookie oil with addition of ZDDP BS Nanoparticles. First of all, I would like to introduce about this project. So as you guys can see, waste cookie oil is so close to the daily life of Malaysian. In recent years, there has been growing concern about waste cookie oil, which leads to improper disposal and the intake for biodiesel production. Also, collecting the recycling of used or uncovered product has been growing in recent years as the increase in the awareness of society towards environmental view. An organized collection of waste cookie oil in large quantities is mainly used to produce biodiesel. Although most research concentrate on the generation of biodiesel from waste cookie oil, there is also another application which is significant and need attention. Waste cookie oil are collected and can be used in the production of biofuel or reused in the chemical industry to make a soap, detergent, lubricants, paint and grease. Furthermore, one of the most popular anti-wear commercially available motor lubricants is ZDDP, both along with HBN nanoparticle addition. The additives are necessary for reducing wear at sliding aspirity contacts. However, they are associated with several environmental issues. The outline for this study is problem statement, objective and scope, literature review, methodology and conclusion. Next, we go to the problem statement. Since the commencement of cookie oil, waste cookie oil has been problem. The lack of standardized method for disposing of waste cookie oil has resulted in various waste management approach. The lack of standardized method for disposing of waste cookie oil has resulted in various waste management approach. Mazini 2019. Another that, according to Panade and Rated 2015, waste cookie oil is manufactured on a massive scale across the world, which has resulted in significant waste management issue. On the other hand, nanoparticle cannot give complete surface protection against oxidation, corrosion or sludge management. As a result, current lubricant development may rely on traditional additives like ZDDP. Due to the problem found in waste cookie oil, to overcome this problem, it suggested to filter the cooking oil waste with the addition of the ZDDP and HBN nanoparticle. To ensure this implement is successful, experiment will be conducted on this study by studying the extreme pressure properties of treated waste cooking oil. Next, the objective for this study is first to filter waste cookie oil as clean base oil for waste cookie oil based lubricant development. 2. To determine the suitable type and composition of nanoparticle to be blended as an additive. 3. To test the extreme pressure for the developed lubricant on the wear mechanism. Next, we move on to the next slide, which is the scope for this study. First, filtering the waste cooking oil as clean base oil according to ASTM D7317. Second, determine the suitable composition for HBN and ZDDP nanoparticles amount to be blended using an ultrasonic homogenizer. Third, testing extreme pressure of the developed sample according to ASTM. And last, fourth, D2783 and validating the wear mechanism occurs. The next part will be the literature review. Classification of lubricant. 3 varieties of lubricant can be categorized based on their physical qualities and performance: solid, semi-solid and liquid, according to Gunn for 2020. Lubrication technology is a great significance in improving the tribological properties and reducing friction pairs. Wear. In addition, lubricants have the function of cleaning wear debris, sealing clearance, dissipating heat and resisting corrosion or rust. In solid lubricants have recently attained significant importance. Graphite and molybdenum disulfide are predominantly used as solid lubricants. They are used under high temperature and high load pressure. According to Cobb-Levin, they can lower the coefficient of friction and wear between two contact surfaces by retaining the direct contact in a rubbing state under high loads. Semi-solid are defined as substances that are neither solid or non-liquid at room temperature. The categorization is divided into 3 categories such as the soda base, lithium base and calcium base. Because a lubricant is put between two surfaces, a semi-solid lubricant can minimize friction between the tool and the workpiece. Grease can be made out of soap split throughout the base oil and is made by supernating fat alkali with hot lubricating oil. Next is the waste cooking oil. Issues related to waste cooking oil is the amount of waste cooking oil produced by the restaurant is high due to deep fries. Panade and rated 2015. The popular dishes in Malaysia are primarily fried, leading to an increased waste cooking oil production volume. Unfortunately, this 7 lead to the plenty accumulation of it and problem of the disposal process of waste cooking oil, according to Camilla 2015. After that, to overcome this problem, literature review will show about the waste treatment. Waste treatment has 2 methods such as filtration and adsorption. According to Alberto Manu 2020, membrane technology employment in vegetable oil processing has grown in popularity over the last 2 decades due to various benefits, including reduced energy consumption, about 50% less than traditional filtering. Nutritional component preservation based on a combination of water treatment and filtration on porous material has been made by Manu and co-workers by designing a recycling mini plant aimed at producing biolubricant from waste cooking oil. According to Rianto 2018, they used kaolin absorbent on metal contraction in waste oil. The sample of waste oil was obtained with the addition of calcium, magnesium, plumbum and chromium because it is predicted that the inclusion of lactic acid will aid butanol in breaking or separating the water content included in waste oil. This treatment can reduce the metal content acquired in the waste sample of waste oil to the maximum extent possible. Next, product testing and validation. According to Zhang 2018, both product manufacturer and component suppliers emphasize assuring the quality of component testing data in contemporary production. Type of wear mechanism have a 3 wear such as the adhesive wear, abrasive wear and fetish wear. Inadhesive wear occurs when a sample slides between 2 surfaces or when a cataract occurs from both sides as the local connection between the solid surface contact. Furthermore, the consequence of this sort of closing is a microjunction, which may be generated by welding between the isolation of opposing bodies on the scouring surface. And then, abrasive wear in the industry. A well-known wear mechanism is an abrasive wear. As a result, abrasive wear occurs when the study material scrapes against a softer substance. Furthermore, if there are just 2 rubbing components engaged in the friction action, the gums is referred to as a 2-physic wear. Lastly, fetish wear. Fretting wear is one form of fetish wear generated by the cycle sliding of 2 surfaces over one another with a tiny amplitude oscillation. Surface fetish is caused by alternating compression tension strains caused by friction. For example, fetish of an engine bearing overlay may result in fracture, propagation up to the intermediate layer and total overlay removal. The next slide will be the chapter 3 is the methodology. For methodology, basically, we will plan the method that will be conducted to achieve the goals of the project. The goal of this study is to test the tribological behavior of the developed biolubricant using the ASTM D4172 standard test method for wear preventive characteristic of lubricant fluid by adding nanoparticle through the filtration method to filter the waste cooking oil as a new lubricant base stock and mixing the filtration of the waste cooking oil using an ultrasonic homogenizer. Besides that, this chapter describes the method carried out to achieve The purpose of this study such as the material selection, sample preparation, testing and surface analysis. Next, material selection. In this study, the types of nanoparticles, base fluid and surfactant agent are selected. The waste cooking oil was obtained from traders who trade in fried foods such as fried banana, keropok or else. There is a wide variety of cooking oil from a plant source such as olive oil, palm oil, soybean oil, canola oil, corn oil, peanut oil and other vegetable oil, and animal-based oil, butter and lard. Next, hexagonal boron nitride (HBN) was used as a sample selection because of its low cost and environmental friendliness. Furthermore, it has a low density, high thermal conductivity, chemical inertness and excellent temperature stability. It is a promising addition because it reduces friction and wears in the base oil. Most mechanical systems can benefit from a sufficient concentration of nanoparticles to improve their tribological properties. A secondary ZDDP anti-wear additive was used. ZDDP has dominated the oil industry for more than 60 years as one of the most studied and finest performing anti-wear additive for engine lubricants. Okay, in this session, the sample preparation step is described. Nanoparticles such as HBN and ZDDP will be mixed with waste cooking oil. First step is filtration. The filtration process is highly effective in eliminating debris in the oil as it purifies treated engine oil into a new finished product that can be used as a lubricant. In order to get a high quality finisher, the filtration process must be conducted using filter paper following ASTM D7317 and then homogenizer process. In this process, to reduce small particle in the liquid, we'll use an ultrasonic homogenizer. In addition, the process will increase stability and uniformity. Each specimen sample will go through a homogenization process. Okay, after filtration, this sample was tested using 4-ball tester according to ASTM D2783 for extreme pressure. The purpose of this testing is to assess the load carrying capacity of lubricating grease in high load situations. The sliding or rolling action of the 4-ball several pressure test equipment is used. A single stainless steel ball spins top 3 stainless steel balls. Everything is entirely covered with a lubricating film or barrier that is held immobile in the shape of a cradle. Next, surface analysis. Using scanning electron microscope to create different warning on the flow of solid object, a high voltage electron beam is used in the scanning electron microscope to create different warning on the flow of solid object. External morphology, texture, chemical composition, crystalline structure and the orientation of the material that forms the sample are all revealed via signals obtained from electron sample interactions. My expected result is reusing discarded cooking oil into a reusable oil. Second, reduce friction and anti-wear using ball tester which is successfully produced. And last, optimize waste cooking oil. And last, thank you so much to all my panel for contribute to see my presentation and Assalamualaikum.